Section 2 of Chapter 5 is an introduction to polynomials. We'll start out with a monomial. Mono, of course, means one. And so a monomial is one term. So it consists of a constant, a variable, or a product of the two. And one specification is that the exponents have to be whole numbers. So the first section of your homework is simply going to be, is this a monomial? So let's look at a few. X squared, is this a monomial? Why, yes, it is, because it is simply a variable and its exponent is a whole number. That simply means that the exponents can't be negative. So this one is, yes, this one is a monomial. All right, this one is, it's got variables, it's got a constant, and they're multiplied together, and there are no negative exponents. So yes, this one is a monomial. Looking at this, this looks like a term, but this has a constant, it has variables, but this variable, because it's in the denominator, remember we just learned that if there's a number in the denominator, then this means that this is a negative exponent. So this is the same as 4m squared n to the negative 1 power. So this is not a monomial because of that the variable in the denominator. 0.56, 56 hundredths, that's simply a constant. So yes, this is a monomial. This one, 3y plus 7, this has to be a constant, a variable, or a product of the two. Because we've added two things together, this is not a monomial, and we'll find out in just a few minutes that this is actually a binomial because it has two terms that are added together. All right, so the next thing we need to know, once you know that you have a monomial, we want to know what is the coefficient and what is the degree of that monomial. The coefficient of a monomial is the number that's in front of the variable, so it's the number part of the term. The degree of the monomial is the sum of the exponents on all the variables in a term. So we don't care about the exponents in front of the number. Hopefully you would simplify that and multiply that out so you wouldn't have any exponents. So the exponents on the variables, you simply count that, and that tells the degree of the monomial. So let's look here. Negative 4x squared, the coefficient is the number in front of the variables. So the coefficient is simply negative 4. And the degree of this, well, we've got an x is our variable and a 2 is the exponent on our variable. So the degree is simply 2. All right. This one, the coefficient, the number in front of, now we've got two variables, but that's okay. We want the number that's in front of the variables. So the coefficient is negative 9/10. The degree, remember the degree is the exponent, but it's the sum of the exponents on all the variables. So we've got an n squared and we've got a p to the 5th. So we're going to add that 2 plus 5 and our degree is 7. So we have 7 variables floating around there that we're going to multiply. All right. Let's see what's next. Let's do a couple more. 5/8 AB. This is a monomial because we've got 5/8 is our whole number, our coefficient. So there's our 5/8. That's the number in front of the variable. And now be careful with this. What is the degree? Well, we've got a to the 1 power. If we don't see a power, then it's to the 1 power. And b to the 1 power. So therefore our degree is actually 2. All right. So if you don't see an exponent, then the answer is, then it's 1. All right, so we've got 2 1s, which makes that 2. All right, on this one, the coefficient is the whole number, so that's 13. And the degree, if you'll remember, so now we don't have a variable at all. Therefore, we don't have an exponent. If you remember, if you've got anything to the 0 power, that's the same as just 1. So we've got a variable just to the 0 power. And that's why we don't have it, because it's equal to 1. So the degree of this is 0. There are no variables there. So the degree is 0. All right, so far so good. All right, so now, so this is in each monomial, and we often call monomials a term. That's a part. Now, a monomial, though, would be by itself. The terms are the parts of what we're going to call a polynomial. Because a polynomial, poly meaning many, a polynomial is an expression that is a sum of monomials. So earlier I said this is not a monomial because we've added something together. If we add something together, now it becomes a polynomial because there are several. A nomial is that term. So an expression that's the sum, and obviously it can be the sum or a difference. If you have a minus in between there, this is also a polynomial. If you have exactly two terms, then this is a binomial. So this one is a binomial because there's two terms added together. Bi is two, just like a bicycle has two wheels, and a tricycle has three wheels. A trinomial has three terms. So the next thing I'll do is I'll give you several polynomials, and I'll say, well, first of all, I'll say, is this a polynomial or not? And then I'll say, what type? Is it a specific type? So we can look here. B plus 2 has exactly two terms, the b and the 2. So this is a binomial. 7r cubed minus 9r squared plus r minus 6 has 1, 2, 3, 4 terms. So we don't have a specific name for that. So we're simply going to call that a polynomial. Anything over 3 terms, we're just going to call a polynomial. So here we have 5.7x to the 4th y. This is just one term. So what do we call it? Monomial, you got it. I hope I'm still on I don't know how low I can go here. All right, x squared minus 7xy minus y squared. So here we've got two minus signs. So here's one term, 2 terms, 3 terms. So this is a trinomial. All right, what if I had one more here that I wanted to show you. What if I had 4m minus 3 over n squared? So is this a binomial? Well, no, it is not. Ha ha ha, tricked you. Because 4m is a monomial, but this 3 over n squared, remember this is an n to the negative 2 power, so this is not a monomial. Therefore, this whole thing is not a polynomial. All right? It just doesn't adhere to the rules that we have for monomials and polynomials. All right, so far so good? All right. So now we talked about the coefficient of each of these is simply the number in front. The degree of each of those monomials, remember, was when we added up the exponents on the variable. So we also may want to know, check this out. I'm running out of space, so the degree of the polynomial. So we talked about the degree of the monomial being the sum of the exponents on that variable. The degree of the polynomial is the greatest degree of any term in the polynomial. So in this polynomial, this crazy polynomial here, y to the 7th minus 3y squared minus 8y to the 9th plus 4y plus 5, all of that craziness. To find the degree of the polynomial, all you have to do is look at each of these terms and find the term with the greatest exponent. And so the degree of this polynomial is simply 9. That's it. Just find the biggest one, and that's the degree of your polynomial. It's a little bit trickier when you have variables that you've multiplied together, but remember, you just add and find the sum of the exponents. So the degree of this term is 5. The degree of this term is 6 plus 1 is 7. The degree of this is 3 plus 3, so it's 6. Oh, I wrote 3. That's funny. Is 6. And the degree of this is just 1. And the degree of the 7, remember, is, do you remember what it is? The degree of the 7 is 0 because there is not a variable. So the largest degree here is the 7. So the degree of the whole polynomial is 7. And it's not because of this whole number, it's because of the exponents. All right? So one last thing. Oh, nope, two last things. All right, so, okay, and I have this one written out too. Oh, it's much quicker if I have them already written out. So that's why I do this. Okay, so then once we know, the reason we want to know what is the degree of the polynomial, what we want to do is we want to, when we put a polynomial into standard form, the reason we have a standard form is so that everybody's looks like everybody else's, and so they match, and so that we can quickly and easily see, oh, yep, we've got the right answer. So what we do is we put them in what we call descending order of powers. That simply means we find the largest power and put it first, the largest degree monomial and put it first, and then we put them in descending order of their powers. So to put this polynomial in descending order of the powers, you would simply find the largest degree is 5, so you would put that one first, 5n to the 5th, plus, be careful on these that when you move them around, you keep the positives and negatives with its term. So this is a -3, so it's going to be -3n to the 4th. And sometimes it helps to kind of mark them off as you go so you know you've got each one. Look to see if there's a third. There is. Plus 2n to the 3rd. Is there a squared? Yes, there's a negative. Be careful. -9n squared plus 4 to the n plus 8. See if you can do this one. Pause it and come back. And now hopefully you already did it because now I'm going to do it for you. All right, the 6 is the biggest, so be careful, the negative. -13t to the 6th. And I'm going to mark it off just so we don't miss anything. And then there's not a 5th or a 4th, so you go to plus 5t to the 3rd. And then we do have a squared term, -4t squared. Plus 2t plus 16. So when you're putting them in descending order of the powers, simply find the largest one and put it first. And you can just rearrange those as long as, don't forget to keep your negatives with the term that it belongs to. All right, once you do that, one more thing. 10x cubed minus 4x squared minus 3x cubed plus 8 minus 5x squared minus 9 plus 6x. All right, if I give you a problem like this, I'm going to do another one here. So you write it down and follow along while I write this. This is why I did those others before. Okay, there we go. We're ready. All right, 2 problems and then we're done. Look at us go. All right. What we're doing here is we want to combine like terms. I think you've done this before. When they're big and long and scary looking, you might freak out, but don't. It's okay. Here we go. What you're going to do is remember you're looking for the largest degree first because we want them in descending order of the powers. So you look for 10x cubed is first. We've got another one, so put it together with the other cubed term, and you can mark things off as you go. Don't forget your negative. No more thirds, so now we're going to go to the squared terms. Mark them off as I go. Don't lose the negative 5x squared, and then plus 6x, and then we've got two constant terms. All right, now they're together, so you simply add together the terms or the coefficients in front of the variables. So if the variable matches, you can combine it simply by adding the coefficients. So 10 minus 3 is 7x cubed. And then the x squares match. Be careful, you've got a negative here and a negative here. So -4 plus a -5 is going to be -9x squared. The 6x, there is no other, so you have to just leave it, plus 6x. And a positive 8 and a -9 is -1. All right? See if you can do this one. Pause it and come back. It's a little bit trickier, but I think you can do it. All right? Here we go. Last problem. So we're going to put them in order, descending order, and we're going to put the terms together. So we've got a -x to the 5th. Let's look to see. We do have one more, plus 3x to the 5th. And then look to see. Now we've got a y, but this also has a higher degree. It's still a degree of 5, but the x term, we're going to put the x to the 5th first, just because after you have a total the same, then you're going to put them in alphabetical order. You're going to put the descending numbers. So we're going to put 6x cubed y squared next. And are there any more of those? Minus 9x cubed y squared. That whole term, keep that whole term together. Don't split up the x and the y because those are multiplied. You can only split them apart if they're added in between. So then we've got a plus 2y here. Oh, and a minus 2y here, and a minus 4. So now when we combine the like terms, these two are the same because they're exactly, the exponents or the variables have to be exactly the same and the exact same exponent to combine them. So 3 minus 1 gives you 2x to the 5th. Combining these, you're going to just combine the coefficients. So 6 minus 9 gives you a minus 3. Keep the whole variable, x cubed y squared. So we've done that part. 2y minus 2y goes away because if you've got 2y and you subtract 2y, there's nothing left. So minus 4, this is your simplified polynomial, and now it is actually a trinomial. All right, it was a longer lesson this time, but I think it's all fairly simple stuff. So I think you'll be able to do the homework fairly quickly. Good luck. See you soon.